Dear students, good morning to all of you. In last class, we have discussed about Einstein's generalization for Planck's quantum theory. So, Einstein's generalized theory able to explain photoelectric effect also. What is photoelectric effect? What is photoelectric effect? Now let us see. Let us take a T surface of metal. To take a metal. This is nothing but metal has atoms like this. It is the surface of metal. Now, light of suitable frequency. Light of suitable frequency is allowed to fall on the surface of the metal. What I am saying is, I have taken one metal and the light of suitable frequency. Light of suitable frequency or suitable wavelength or suitable wave number is allowed to fall on the surface of the metal. Very interesting observation. Once again, what we are doing here, when light of suitable frequency is allowed to fall on the surface of metal, one interesting observation, that is, electrons are ejected. Electrons are ejected from the surface of metal. Electrons are ejected from the surface of the metal. This observation is called as photoelectric effect. What is photoelectric effect? When light of suitable frequency is allowed to fall on the surface of metal, then electrons are ejected from the surface of the metal. This observation, this phenomenon is called as photoelectric effect. What is photoelectric effect? It is the ejection of electrons from the surface of the metal when the metallic surface is irradiated with light of suitable frequency or wavelength or wave number. This is called as photoelectric effect. The electrons ejected in this phenomenon are called as photoelectrons. What is the thing we have discussed now? When light of suitable frequency is allowed on the surface of the metal, electrons are ejected from the surface. This phenomenon is called photoelectric effect. We have to conduct this photoelectric effect in hard glass tube. Hard glass tube. You have to take a metal plate. This is a metal plate. So here, this is plus means anode. This is anode. This is a cathode. This is minus. Plus battery is connected. This is ammeter. So we have to take hard glass tube, we have to put metal plate, and here as anode we can take another metal also. So when it is connected to battery, here, see here, now light is allowed to fall on the surface of the metal. Light is allowed to fall on the surface of metal. Then what happens? Electrons are ejected from the surface of metal. These electrons move in this direction. phenomenon, photoelectric effect. You have to take a hot glass tube and you have to take metal plate which acts as cathode. You have to take another metal plate acts as anode. Here and connect it to like this. Then when light is allowed to fall on the surface of metal, electrons are ejected like this. Now, how this phenomenon occurs? How this phenomenon occurs? When light is allowed to fall on the surface of metal, electrons ejected. How this phenomenon occurs? It is not explained by the classical theories which are already present at that time. Then Einstein is able to explain this photoelectric effect, how it occurs. Einstein is able to explain this photoelectric effect. Here, this phenomenon involves photons and electrons. That's why the name photoelectric effect. Photons fall on surface, electrons ejected from surface. That's why photoelectric effect. How it occurs is not explained by earlier classical theories. This is successfully explained by Einstein by his generalized quantum theory. Einstein's generalization is here used here to explain how the photoelectric effect occurs. Okay, for this Einstein awarded Nobel Prize for the explanation of about photoelectric effect. According to him, now let us see the Einstein's explanation for the photoelectric effect, how it occurs. So Einstein's explanation: when light is allowed to fall on the surface of a metal, the light photons strikes electrons. When light is allowed to fall on the surface of the metal, the light photons first strikes electrons. One photon can strike only one electron. One photon can strike only one electron at a particular instant of time. One photon can strike only one electron. Okay. Now we are going to know about the Einstein's explanation for photoelectric effect. Okay. Now, one photon can strike only one electron at a given instant of time. For example, like this. This is the nucleus. This is the electron. Okay, photon strikes this electron. Then the energy of photon is received by electron. Consider the energy of photon Consider the energy of photon is equal to h mu, you know very well, or sc by lambda, you know, or mu is equal to c by lambda. Sc mu bar. Then the energy of photon is received by electron and causes the photon and causes the photon to disappear. Causes the photon to disappear. So what I am saying, during photoelectric effect, one photon strikes one electron. Then the photon energy is taken by electron. Then photon disappears. Consider the energy of photon is equal to h mu sc by lambda h mu bar. For the discussion, I am saying 100 rupees. For you, I am saying 100 rupees. Okay. Now this is with the electron. Now it is taken by electron. Now how the electron uses that energy? Now let us see. A part of released energy. A part of energy of photon. The part of energy of photon. For the discussion, I am saying 60 rupees. A part of energy of photon used by electron. To overcome the attractive forces. Between attractive forces with the nucleus. This used energy is called as work function. Inside the atom, some work is occurs. This energy is called as work function or threshold energy. Work function, or this is also called threshold energy. So what I am saying, how the photoelectric effect occurs? One photon strikes one electron. Then photon energy is taken by electron. Consider photon energy 100 rupees. Now the 100 rupees is now taken by electron. So what is the energy of electron? 100 rupees. Out of 100 rupees, electron uses 60 rupees to overcome the attractive forces. Attractive forces are there. To overcome these attractive forces between nucleus and electron. Electron uses 60 rupees energy. The 60 rupees is called work function or threshold energy. Still, how much energy remains left at electron? 40 rupees. The electron will come out with those 40 rupees as kinetic energy. How the photoelectric effect occurs? Very simple. First, we have to allow the light to fall on the surface of metal. Then, light photons strikes electrons. One photon can strike only one electron at a given instant of time. Consider photon energy how much? 100 rupees. Then the 100 rupees is taken by electron. The electron uses the 100 rupees in two ways. 60 rupees to overcome the attractions between nucleus and electron. That 60 rupees is called work function or threshold energy. Remaining 40 rupees appears as the kinetic energy of photoelectron. Photoelectron is nothing but electrons ejected. So remaining energy appears as, so 60 rupees here used. Remaining 40 rupees, it will come outside. So the remaining energy here, how much? 40 rupees, am I correct? Appears as appears as appears as kinetic energy of photoelectron. Photoelectrons are nothing but the electrons ejected in photoelectric effect are called photoelectrons. Appears as kinetic energy of photoelectrons. So what I am saying simply, energy of photon, how much? Energy of photon. Energy of photon, comma, E is equal to H. Okay, and it's 100 rupees. 100 rupees. Am I correct? Work function. Work function. It is denoted by W. It is also called threshold energy. Threshold energy. Threshold energy is equal. We can take for energy H. That's why it is also energy. That's why we can use the term H nu naught. H nu naught. H nu is the energy of photon. H nu naught is the work function of threshold energy. Is equal to C mu bar naught. Since mu is equal to C mu bar, we can write like this. Is equal to Hc by lambda naught. Since mu is equal to C by lambda, what is the value we said here? 60. 100. Then kinetic energy of photoelectron. Kinetic energy of photoelectron is equal to how much? H nu minus H nu naught. What is this? H nu minus H nu naught. It is nothing but 40. Energy taken by electron from photon, how much? 100. C used for work function. Remaining 40 is kinetic energy. 60 plus 40 is equal to how much? 100. Like that we can say. So what I am saying about photoelectric effect, very simple. Light is allowed to fall on the metal surface, then electrons are ejected. This is called photoelectric effect. The electrons ejected are called as photoelectrons. Okay. Now, how it occurs? Very simple. Photon strikes electron. Then electron takes the energy of photon of 100 rupees. Electron uses 60 rupees to overcome the attractive forces. This is called work function. Remaining energy appears as kinetic energy. Okay. Now, I am going to write here. So what we understood here, H nu, that is H nu is equal to H nu naught 100 rupees, 60 rupees, 40 rupees. Am I correct? This is the energy of photon. It is a work function. It is a kinetic energy of photon. 100 for our discussion. This is taken by electron. Electron uses some energy for work function. 40 rupees is nothing but kinetic. For the discussion, don't write in the examinations these values. For the sake of our convenience, I have written those numbers. Okay. Now, from this, I am going to write like this. Kinetic energy of photoelectron is equal to H nu minus H nu naught. So, H, let us take now. Nu minus nu naught. Kinetic energy is equal to what we can write? H nu minus nu naught. It seems to be Y is equal to mx form. Y is equal to mx form. That's why I'm writing here. Graph, let us take kinetic energy and minus mu naught. So the graph will be like this. So this is y, this is x. So slope is equal to how much? H. Slope is equal to Planck's constant. The value you know how much? 6.625. 10 to the power of minus 34 joules per second. So like that K is equal to mu minus mu naught. And I am going to say one more thing here. K is equal H into mu minus mu naught. Suppose, listen carefully, very interesting point. Suppose frequency of light 5, let us consider. Okay, mu naught, what function value? 5 minus 2, H 11. What is the value of kinetic energy? Isn't it? Okay, if mu is equal to 5, mu naught is equal to 2, then what we get? Kinetic energy V. If frequency of light is doubled, if it is doubled, now let's calculate kinetic energy. If it is doubled, what we get? We get kinetic energy 8H. From this, what we understood? Very, very important point I am going to say here. If frequency of light is doubled, if the frequency of light, in examination they will ask, the frequency of light is doubled, what is its impact on kinetic energy? Kinetic energy here 3H, here 8H. You take double 6H. The value is more than double. So if the frequency of light is doubled, 5 becomes 10, then the kinetic energy becomes more than double. The kinetic energy of photoelectron, the kinetic energy of photoelectron, the kinetic energy of photoelectron is more than double. What is the kinetic energy when frequency is 5? 3H. If it is 10, 8H. It is constant. It is the constant. That's why we should not change. If it is double, it is constant. That's why 8H. So more than double. I want to say that point. Very, very important. In examinations, they will ask this point. Suppose if the frequency is tripled, now let us see one more. H 15 minus 2. The frequency of light is tripled, then what we get here? 13H. You take 3 times. 3H becomes 3 times means 9. More than tripled. If frequency is tripled, kinetic energy is more than tripled. If frequency is doubled, kinetic energy is more than double. So next point, if the frequency of light is tripled, if the frequency of light is tripled, then the kinetic energy of photoelectron is more than triple. So to say these 2 points, I have taken that example. What is the effect of frequency of light on kinetic energy? If frequency is changed, kinetic energy also changed. If frequency is doubled, kinetic energy is more than doubled. If frequency of light is tripled, kinetic energy of photoelectron is more than triple. I want to say that point. So that's why I am giving one example which is useful to you to understand these 2 points. Okay. So these are not calculations. Just I am giving one example to understand these 2 points. Understand or not? Sir, what is 5? What is just I have taken? It is the frequency of light. It is the threshold frequency of 5 minus 2, 10 minus. If it is double, it is more than. Am I correct? It is more than. If it is a triple, it is more than triple that is. I want to say that more than triple. Okay. Okay. So like that we can say KE is equal to KE is proportional to mu. Am I correct? Not proportional, exactly proportional. KE increases with the increase of frequency. I am going to show you kinetic energy frequency. See here, K is equal to mu minus mu naught. This is a constant. Am I correct? So let us start from here. This first point. This is called mu naught. Threshold frequency means starting point. Starting point is one. The graph will be like this. Okay. So what I am saying, kinetic energy depends upon frequency of light. If frequency is double, kinetic energy is more than double. If frequency is triple, kinetic energy is more than. So the video becomes too large, very difficult to download. That's why I am going to say the remaining part in the next video, now only. Okay, I am going to stop now. Let us continue in next video.